Inside this EV battery recycling factory, old battery packs become valuable materials for future batteries. A single EV battery pack contains many valuable material streams. Old EV battery packs arrive at the recycling facility on secured pallets.
The packs are staged in controlled lanes before inspection.
Weighing records the incoming mass before recycling begins. Registration tracks each pack through the factory process.
Safety inspection checks for damage before the pack is opened. A thermal scan helps identify hidden battery risks.
Voltage is checked with insulated tools before discharge. The remaining electrical energy determines the discharge process. The pack enters a controlled discharge system before disassembly. Controlled discharge reduces electrical risk before the pack is opened. After discharge, the pack moves to the disassembly line. The pack is secured before workers remove its outer casing. Bolts are removed so the outer protective casing can be opened.
The casing is lifted away to reveal the modules inside.
Technicians inspect the internal modules before separation.
Protective covers are removed before bus bars are disconnected.
Copper bus bars are removed as a valuable metal stream. Wiring harnesses move into a copper-rich recovery stream. Aluminum cooling plates are separated from the battery pack structure. Battery modules are lifted from the pack one by one.
Removed modules are staged safely before cell-level processing.
Each module is inspected before the cells are separated. The module casing is opened carefully to expose individual cells. Cells are separated from the module structure for controlled recycling.
Cells are sorted by condition before entering the next stage.
Damaged cells are isolated for special safety handling.
Cells are discharged before enclosed shredding.
Controlled discharge lowers the risk before material recovery.
Discharged cells move to the enclosed shredding line. Discharged cells enter a sealed shredding chamber. Cells are shredded inside an enclosed system to control risk. Dust and gas control protects workers and keeps the process contained. Screening separates fine black mass from larger metal fragments. Black mass is collected in sealed drums for further battery material recovery.
Samples are taken to check the quality of recovered black mass.
Copper foil is separated as one of the valuable battery metal streams.
Aluminum foil becomes a separate recoverable material stream.
Light plastic separator material is recovered from the shredded cells.
Graphite-rich material is separated and sealed for downstream use. Pack casings and cooling plates create a large aluminum stream.
Aluminum parts are compacted into blocks for transport. Busbars and wires form a clean copper-rich stream. Copper parts are processed into reusable copper granules.
Copper granules are packed for reuse in new manufacturing.
Black mass enters a closed material recovery process.
Closed refining equipment separates battery metals under controlled industrial conditions.
Filtration separates solids from battery material solution streams. Lithium-bearing material is recovered for downstream battery material production.
Nickel-bearing material is separated as another important battery stream.
Other battery metal streams are recovered in sealed industrial systems.
Graphite-rich material is cleaned and dried before packing.
Recovered materials are dried before quality testing and packing. Lithium-bearing material is sampled for quality control.
Nickel-bearing material also goes through quality testing.
Quality control connects black mass to recovered battery material outputs.
The recovered outputs show why EV batteries are valuable recycling resources.
The first stage receives, weighs, and registers old EV battery packs. Safety testing and controlled discharge reduce risk before opening the pack. Pack disassembly separates modules, copper, aluminum, wiring, and casing parts. Modules are opened so individual cells can be sorted and discharged. Discharged cells are shredded inside an enclosed safety system. Black mass is the central material stream in battery recycling. Copper and aluminum are recovered as separate metal streams. Closed refining separates battery material streams under controlled conditions. Recovered materials are sealed, packed, and shipped to new manufacturing supply chains.
An EV battery pack is heavy, complex, and built from many modules. Modules are the smaller building blocks inside the EV battery pack. The individual cells must be inspected before shredding.
Copper appears in busbars, wiring, and battery foils.
Aluminum from casings and foils becomes another valuable output.
Black mass contains the core material value of many lithium-ion cells. Lithium-bearing material is one of the key recovered battery streams. Nickel-bearing material can return to the battery supply chain.
Graphite-rich material is another recovered battery fraction.
Recovered materials can support new battery manufacturing after downstream processing.
Battery recycling depends on strict worker safety at every step.
Fire-resistant storage and monitoring reduce risk during battery handling.
Closed machines and filtration systems help control dust and emissions.
Equipment is inspected after each batch to maintain safety and consistency.
The shredding line is cleaned and checked before the next production run. Closed refining systems are inspected and cleaned between batches.
Each recovered material stream is packed separately. Lithium-bearing material is sealed for downstream battery processing.
Nickel-bearing material is packed in sealed containers.
Graphite-rich material is sealed for safe transport.
Recovered copper is packed for reuse in electrical manufacturing.
Aluminum blocks are palletized for shipment.
Black mass drums are sealed before warehouse storage.
Recovered materials are palletized by material type.
Stretch wrapping secures the material pallets for storage. Warehouse stores recovered battery materials before shipment. Inventory tracking connects each shipment back to the recycling batch.
Recovered materials are staged for shipment to downstream manufacturers.
The recovered materials leave the plant in sealed shipments.
Recycled materials move back into industrial battery supply chains. EV battery recycling starts with safety before material recovery.
The value of the pack comes from many materials hidden inside the cells and structure.
The pack is broken down step by step until cells and structural materials are separated. Discharged cells are processed into black mass inside enclosed equipment.
Closed recovery systems separate black mass into useful battery material streams.
Structural and electrical metals become copper and aluminum recovery streams.
The finished outputs show how old EV batteries can become materials for future batteries. A battery recycling plant is a coordinated system of safety, disassembly, separation, recovery, and packing. First, the factory makes the battery pack safe for disassembly. Next, workers separate the pack into modules, metals, and structural parts.
Then, cells are discharged and processed into black mass.
Finally, the factory recovers valuable materials for new supply chains. Recovered materials are packed and shipped for downstream manufacturing.
What looks like a dead battery can become a source of future battery materials.
Battery recycling helps return valuable materials to the battery supply chain.
In EV battery recycling, safety is the foundation of every process step. Modern recycling uses enclosed equipment to recover materials safely and consistently.
The final outputs include metals, graphite, black mass, and battery material streams.
The warehouse stores the recovered materials before they move to new factories.
The recovered materials leave the recycling plant for downstream production.
The key steps are receiving, testing, discharge, disassembly, cell processing, black mass recovery, refining, packing, and shipment.
From old EV packs to recovered battery materials, every step depends on safe, precision, and controlled recovery.
Thank you for watching Mega Processing Tech. Subscribe, like, share, and comment what future recycling factory we should explore next.